welcome to AMA Expo Express, sponsored by Motion RC. I'm here with Spec CNC. He's getting some stuff ready real quick.
There we go.
Why don't you introduce yourself and your company?
Yeah, so my name is Paul Voss, and I'm the founder of Spec CNC. We make the lowest cost, easiest to use CNC machines on the market. These are there's a foam cutter that will make any airfoil you can dream up. It'll make fuselage parts. It's perfect for modelers, clubs, inventors, schools, all that kind of thing, and it's really fresh off the line. These are the first three that are coming out of production here. I'll just say a little bit about the philosophy of this machine before we get into how it works, and we'll give a demo and show people how to make some planes and things. I teach engineering at Smith College, actually, and have access to just fantastic equipment and machinery, and I've always been interested in bringing this out to high schools and outreach programs. And the issue is you can't take a pickup truck full of equipment out, and the high schools can't necessarily afford the technicians and the IT folks and everything to maintain all these machines. So you'll notice what's not on the table here. There's no computer. There's no big box of equipment. Everything runs on this machine here, and the interface is with an SD card, so that it's a really simple interface, and that you don't need CAD software. You can change things like the profiles you're using, the airfoils, the chord, the washout, the twist. You can make any shape you want with a text file, and just edit that in, say, Notepad or text edit on a Mac. So you don't need specialty software. It's also intended to last a very long time. In other words, not to have those issues that in 2 or 3 years that Windows is updated and it won't connect anymore, can't find the driver, and so as long as you can read an SD card and change a few numbers in a text file, you're good to go, and this machine's going to keep working. I'll say another piece on this. The mechanism is very special and unusual. It's got 4 motors that actually wind strings that move the hot wire around. This is the hot wire that actually does the cutting. And this was something I started working on 5 years ago. 2 years into it, I found a fellow in Germany, a very smart guy, Hans Sebold, I believe his name is, who had come up with this a couple years before and had big systems hanging in his garage of motors. And so hats go off to him for originally coming up with this invention. But he was very generous in that it's in the open source, and so I didn't have to stop my project when I realized someone else had done it. And so this is a really clean implementation of that, with a lot of thought done on the engineering to make it work really nicely. And whereas originally it was designed for schools and maybe it would cut some decent wings, what I'm finding is that it's cutting really, really high quality stuff. The feedback I've been getting from people at this Expo here has been really heartening, that people have been making wings all their lives can't believe the quality of the profiles. So, and that's largely because of the string drive mechanism. There's no backlash. It's a positive control. It's a very inextensible special strings that we've found over the years of working with many different materials. And so what I'd like to do is jump right in and show you how to build stuff, because that's what people want to hear. So let's do a quick thing. Often you'd come in. I'm going to use this Foamular 250, which is inexpensive. You can get a piece of this 2x8 for about $13, and you can make a whole lot of gliders for an outreach program for that, or make beautiful stuff, and it cuts real nice. And there are other foams out there. This will cut the combat foam and the other things with a little bit of adjustment to get the heat up, but we'll just cut this foam. I used to do this with a table saw, and very dangerous to cut foam on a table saw. It binds. So now I just bring it into the shop. There's a number of different files on the SD card. So the first one I always have on there, and I can set these, and you can as a user. The first one I usually put is a vertical cut, because it's super useful just for chopping up the foam. So I'm going to put this piece in here. And Dow has started scoring these pieces of foam in ways that are not helpful to modelers. So I'm going to cut that piece off right now. And this is just a high heat, fast cut to just get the foam down to size. So this might be imagine a 8-foot long sheet, and then we've got it into 2 4-foot sections or things that we can work with. And once in a great while, we'll do this and get it bound in there. So this is just a great thing to show that we can easily run it back, get the heater back on. So I didn't pull it away quite fast enough doing the demo. Because it was meant for schools and it's got a completely integrated system, it actually automatically turns the heater off at the end of the run. So you don't have any issues of heaters running when you don't know they're running. So that's what I did there. I just moved it back and turned the heater back on, and we're good to go. Often you'll do a little bit of adjustment, especially if it's been in a center like this or carried around. And so let's cut an airfoil. I'd like to cut what's a nice one that's hard to cut. It's under cambered. The small airfoils are super hard to cut on foam cutters. So we're going to go small. Not the smallest. I'll show you some of those, but we'll go small and we'll go a thin under cambered airfoil. This is just one I happened to come across. It's called a mid 105. It seems to work nicely with rubber powered aircraft, and I just put it on here as a quick show to. So I'm selecting file 3. This is the mid 105. In my little text file on here, the first line is a comment line. I can put anything I want up to 16 characters and it shows up there. So it reminds me what that file is. So right now, if I push the button, it's processing. It's doing a whole lot of math to figure out if I want a mid 105 with the chords specified there, that and any twist or washout, and also figuring out how the string should move. So that's if you did hand calculations of what it just did in that time, it would take you a year to do that. So there's a lot going on in that little computer. We'll show that in a minute. The run button's simple to use. It always takes you to the next step. So in this case, to move to the initial position. And I'm going to put down a nice clean piece here. And almost anything can work as a weight. I managed to leave the little weights in the box there, so I'm not going to get them out. But and you just push run to go. So unlike many CNC machines out there, a lot of them are either sort of big and dangerous. They have spinning spindles, high-speed things, or very higher voltages. The machine that I use in the lab can accidentally easily have 120 volts across it if you're not careful. This is all a 12-volt system, and unlike a 3D printer or something else you might use in the classroom, which would take 8 hours to print, here we just pop this out real quick, and we have a piece. You can run these fast enough. The idea is that kids could get involved and be making these, maybe selecting an airfoil out of a little set. This is the easiest, the basic use, where someone would have 3 or 4 different airfoils and several stabilizer sections, and just by pushing a button, the kids could choose those. And then here you can see the quality of this. And this is with really no adjustment. Someone who's fine-tuning things and working with the heat and stuff can even get a little more in the offsets. Everything's fully settable. The offsets, the heat levels. Just show a couple other things while I'm at it. Here's a nice 80-20. So this is commonly used for stabilizers. It's a low Reynolds number, high efficiency airfoil. This is a small one. So this mid 105 that we just cut in the 80-20, one of the neat things that a sort of club could do with that, for the cost of a stick of wood, you can make gliders in mass, and you can, out of one sheet of foam, in theory, you can cut about 60 of these gliders. So that's $13 for 60 gliders. It starts to be very affordable for a club with one of these machines to give these kind of things away or let the kids work with them. This is a kind of a neat design. It's just got a binder clip here on the back so it's a few cents a piece that a club could even make, and they can be. You can adjust the angle of attack, which is very useful, and the center of balance. So it's similar to a lot of the little gliders out there with two major differences. One is you can cut your own airfoils, and these are real 3D airfoils, and in addition to that, you can have full control over the angle of attack and the balance point. The angle of attack is the single most important thing that you want to optimize in terms of performance. You want to get the highest overall lift to drag. That's not the highest overall lift to drag for the wing. It involves the drag of everything else. So you really, in terms of getting that best flight, that longest flight, that angle of attack is a key parameter. And to be able to adjust it for a few pennies and have a whole bunch of kids do it is, and this plane has another little feature that I've developed, which is these glue-on tabs that then can be used to adjust for any. The foam is quite rigid, so if you don't glue it together exactly right, it'll roll left or right. So it's really nice to have these aileron tabs here to trim it. I'll show one other piece of that before we go back to the machine. This is a really neat product that I've started to use. I just found these. These are great for outreach programs. It's a cool tool. It runs super cold on the hot glue, and the kids can't hurt themselves with it. So you can literally squeeze this on, take your finger, smooth it out, and it runs. This one happens to run on a battery for about an hour, which is really nice for a field. Want me to say a word or two more about what's under the hood here, or should we? Yeah. I don't want to take too much time out of other folks. And
no, you're good. Why don't you go ahead and just give us a little bit more, and then we're going to cover the specs bit in general.
Okay. I'll show two more things. We're not limited to just wing sections. A little more advanced user can make really nice fuselage parts. This is an idea. It was just cut at 3 in the morning. It wasn't tuned. You can see where the wire cut in and out there, but you can get a sense of the accuracy of the machine. Hot wires are tough to do that kind of thin cuts like that, and so these weigh almost nothing. You could literally make a fuselage. You could glass it. I have myself. In fact, that picture right there is taken from an aircraft made on this machine with glassed and carbon fiber spars, and so the folks who are doing more advanced stuff can easily do that as well. I'd like to show just a little bit about what's under the hood. This is really special. This is normally when you get a machine like this, it would have a Raspberry Pi and an Arduino. There would be a big mess of hats and electronics and wires, and it wouldn't fit cleanly like this, and it wouldn't be as reliable. So what I've done, I've been working with these what are called Propeller Chips, or Parallax company in California that makes these fantastic little chips. They have 8 processors on them, and so I build these boards. They're built in Deerfield, Massachusetts. I designed them. And what it has on here, it's a full CNC controller, essentially. It has 4 motor drivers and a heater control. Has a user interface to the buttons. It has an SD card reader. And literally the motors just plug in on this machine, and everything's there, which means it's super reliable. You don't have wires to come loose and break. And I've just found these they come out of the box, they work every single time. So just how they come, very briefly. Let me grab one thing here that I left underneath. Over here is how the unit comes. So unlike many CNC machines, this comes basically fully assembled and tested with a few screws taken out so it can pack flat and ship. So this is really different than your sort of low-cost CNC machine where you might get a bag of bolts and parts and some instructions that are barely readable, and good luck trying to get it working and try to figure out what software you need to use and what computer you need to connect to it and all that. This comes out of the box, and literally within about 15 minutes of the user opening it, they can push the button and run some of these demo files. And then as long as they can put an SD card in a computer and change a few numbers, 10 minutes, 15 minutes after that, they can have their first airfoil. So it really is meant to turn this whole maker world in aeronautics upside down and make it super easy to do the creative, the design piece, where you can try stuff and iterate and not spend weeks or months on every single iteration, and you can really explore the space. Aeronautics is super complicated, and there's a lot of stuff going on, and to be able to explore that space quickly is really powerful.
So from what I understand, this is so recent that your website isn't even online yet, right?
That's true. We're trying to figure out the e-commerce thing, to decide how we're going to handle that. Initially, we're going to keep it super simple. I got so many people signed up to order this stuff that that we're going to have a very simple interface to start with, and then over the summer we'll get the full e-commerce and the PayPal and all that. But we may just do bank checks to start. And I had people wanting to pay me cash on the floor yesterday and opening their wallets, and we're not registered with the taxes, so I won't take that. And in addition, I'm a perfectionist, and so there's a few little things on the firmware that before it goes out to customers, I just want to get perfected. Like it works beautifully on the floor, but there's some features that I want to add, and so we're going to ship at the end of March, and that's pretty definite. We have the parts in stock, the hardware's all there. The first essentially 20 to 25 will be available at the end of March, and after that it could be, depending on the demand, it could be a long time. So
do you kind of have a price set for that?
Yeah, the price is $795 for what you get in that box. And I want to be very clear with the users, this has a light on it for bling at the show. The basic unit, which is a $795, is right there. It doesn't include the LCD because it's not a critical component. It doesn't add any real functionality. It makes it a little easier to use, but not everyone wants to buy it. So I've pulled that out of it and keep the base price $795. And the lowest cost foam cutter that I know after this, if someone doesn't build it all themselves and spend months on negotiating open source, is about $5,000. And that's it's a longer span, and it is a really rugged industrial unit, but I've had, the quality of the cuts when I've used it is no better than this. In fact, this is probably better because it's smaller and more rigid, and it's really clean, especially for those smaller profiles. So there's often, you'll see lower cost stuff as well, which is the hidden costs. They don't tell you that, you need to have a computer sitting next to it, and you need to have a heater, Variac, to control the power supply. All that is built in with this one card that we have manufactured. So that's really brings the cost down. And the last thing I'd like to say is I'm a huge believer in making everything in the United States that we possibly can. So the circuit boards are built here, they're designed here. All the metal fabrication's done by a company 20 minutes from me with laser cutters the size of a truck. We have the woodwork is done by the fella in Massachusetts who's has a little. He's been in business with this sounds morbid, but I'll say it's a good story. He's in business with Florence Casket Company, which is the oldest casket company in the United States, and he and his wife have a separate business in Vermont, and they know woodworking. His separate business does many other things with wood, and so he's really nice craftsmanship, all made in the U.S., all stainless steel hardware. Everything simple to keep the cost low, but nicely made so it'll hold up. And
perfect. Real quick, I'm going to check in with our Ashley, who's monitoring social media, see if there's any additional questions.
Okay, well, Jason asked if you had a website, which you guys didn't answer that. How can they get in contact with you?
So here's the way it works. The website is speccnc.com, so it's Spec CNC, all lowercase.com. It's going to be up on March 10th. That's when I'm setting. So, I'm going to leave it at that right now. There's been so much interest that I'm worried about barraging my personal email business account with just so much that I can't do the work I need to do for these people to get it out the door. So, I'm gonna just say when that comes up, and there'll be a contact email there, and that would be a great time. They'll have a chance to read through the questions, look at things, and
And if you'd like a quick overview too, we'll also have this on modelaviation.com. You have a press release that kind of just goes over the features of this product in general, so you'll be able to see that as well.
That was actually another question.
Okay.
And the last question was from Michael, and he wants to know what design software you're using.
that's the beauty of it. I'm not using CAD software, so there's a whole range that users can check in, right from the STEM teacher who gets this out of the box can put in 6 screws and push the button and run the 9 programs to make various gliders, right? Up to the next level where that teacher or someone who's working in aeronautics would like to put the SD card in and change the chords. You can do taper, you can do twist. More advanced than that, I really like the University of Illinois Champlain website. They have 1,600 airfoils online there. And in a normal situation, you would have to go get the airfoil, import it into your CAD software, maybe put an offset on it, export it, hope all the compatibility works. That's not the way it works for this machine. It literally, you copy paste. If you can copy paste and grab those coordinates, you paste it into a text file, and 5 minutes after you've been on the UIUC website, you're holding the airfoil in your hand. And you don't need to maintain a software license or fuss with the other things that, and even so, and so more advanced users still can define their own shape files, and you could do that through your favorite CAD program and export a bunch of coordinates. I call that for advanced users. They may have to fuss with it a bit, but if you put a set of coordinates, it'll cut it, and you can even have a separate set of coordinates on each side. So if you can, say you wanted to, blend an RG14 into a symmetrical airfoil, okay, 80-20, right? And you could have those 2 airfoils on both sides, or you could have your own 2 shapes on both sides. And as long as those files are the same number of points, there's a little bit of work on the user because the wire just moves to this. You have to have it move in synchrony. There's no limit on what a user can do with this. Every motion that the machine can do in the X, Y on both sides is available to the advanced users.
All right, well, thank you so much for giving us
Yeah, great to talk to you. And I want to say I'm really impressed with all the work that AMA does and promoting essentially STEM education at a time when we really, really need it in this country. And you guys are just great, so thank you, and keep up the good work.
All right, well, thanks for that. Yeah, we're definitely trying, and you can check out what the AMA Foundation has been doing to try to raise money to help continue these programs in our recap from yesterday. We will be live again at 11 a.m. with some new products from Extreme Flight, so make sure you check in then. And again, visit modelaviation.com/expo-express. Information on this will be available shortly.
Yeah, thanks so much.